and if my that is network gets unstable, I may be logged out. So I am making someone co-host. Rule number 19. Are you here? Jagrit, are you here? Jagrit Dasgupta?
Yes, sir. Present.
Okay, I'm making a co-host right now. So if I log out, then you will be the host. Okay, but whatever, it is being recorded in my cloud. Nothing to worry. Okay, so this is the code I have provided to all. So again, I am providing the classroom code again. You can join, and just let me share the screen. What will be our syllabus? This is our lesson plan. 13 topics. The last topic I may not be able to complete, but the other 4 topics we have to complete. That last topic I will try to as much as possible. The advanced topics, the cloud-based software as a service. And today I will discuss the basic things. And you can see the orange color topics means these are from actually here. We have to solve some numerical problems that will help our technical rounds and also in other PSU exam, ISRO exam. You can see recently 5-6 questions on an average. These questions are coming in several exams also. And green symbol, this is object model in UML. UML is mostly important. So if you do not know about UML diagrams, then you are actually whenever interview panel, they will ask that whenever software engineering comes, UML diagram you have to know. Okay, and the other things are also required. So just I'm closing over here. I'm resharing my screen. I think you can see my screen. So since I did not got any answer, so I think I can start from the beginning here. What is software engineering? First of all, what is engineering? What is engineering? Engineering means it is an actually mathematical and disciplined approach. Mathematical and disciplined approach. Mostly mathematical means we have to follow the logic, mathematical logic also, and discipline means there is some step. We have the engineer should have the insight that what if we are doing some action today, what will be the impact of its in future, and also he or the engineer can learn from the previous experience, previous failure also. Software engineering just adds software before engineering. So this is the same thing. Software engineering is mathematical and disciplined approach to develop a software so that we can make the software in that is cost effective and less amount of time. That is to mathematical and disciplined approach to develop a software within the required time or deadline. That is time constant is a major thing here, and also cost effective. Cost of software, you can see that earlier days cost of hardware are much more compared to the software, cost of software. But currently cost of softwares are getting much more expensive compared to hardware even. So So you have to deal with this. So you have to maintain the deadline. Suppose I want a software to develop by 2 months. So you have to submit. You have to give me the software by 2 months. If you can extend, okay, some understanding is there between the client and the developer. But how long the user can wait? If the user cannot wait indefinitely. So indefinitely, no one will wait for you. So you have to submit. That is, there are lots of competition there, lots of organizations, software development organizations are there. So they are in competition. So whenever one person will see that you are giving this software, but it is very much high price, your cost is very much high. But of course, find that there are functionalities are very, there is more functionalities are there available in your software. But also in the market, other companies are providing the software, maybe less number of functionalities are there, but it is okay. But and also that it is affordable. So when that is, user will go to that one which is cost effective, which is affordable too. Maybe he can that is he will that some of the things like you have to that is you means the point from the user point of view. So maybe the all the functionalities are not exactly same, not high end, but he will go for this which is cost effective. So not only the software should be good quality, and also it should be cost effective, and also it should be submitted within deadline. Okay, so the software engineering means is whatever I have written, mathematical and disciplined approach to develop a software. And why we need or why we require software engineers, still today also we need many software engineers. That is, they are very much skillful, because software, again I am saying, it is day by day it is becoming expensive, and there are very less number of maybe sometimes we can see when user faces any problem, so you need to maintain, suppose you need to debug, so there are lots of persons are required. So this is the issue here. So this is known as software crisis. What are the crises again? I mentioned again that if the software is there is some need to change the software, there is some issue, then you have to debug it. And suppose there are several crashes there, so user will report to you, sir, my the software you provided to me is not working well. It is frequently crashing, and also it is not suitable in my Windows or Mac OS. So you have to look for it. So there, that's why you need more software engineers. Though those are very much skillful, and you have to. That's why we should have the knowledge. So whatever. So now I am coming to the actual part. What I have shown you in the lesson plan. Software life cycle. First, I will tell you software life cycle. Maybe in MOOCs or whatever, if you have started from your interest or not, so it may be seen, mostly it is observed that this subject is very much boring, mostly is theoretical, but that's why I will use not lots of numerical problems that actually come in our placement, and also other maybe online that is off campus, on campus, whatever. But if you understand the story behind, then it will not so much boring. That you can see after this class also. Software life cycle. What is life cycle means? Suppose from the start or generation or creation and up to the death, that is up to the completion, you can say. This is a life cycle. Software life cycle means from first of all, you have to meet your client. First, client or user will sit in front of you. Then he or she will tell you that what is the requirements that they want. After you collect the information from the users, then you have to start designing and coding and testing whatever, then handing the software over to the user. So this is the entire software life cycle. So we can say software life cycle is a series. After the basic discussion, I will tell you some like waterfall model, several models I will discuss. So just right now, just I'm mentioning a series of different stages. As we know in any life cycle, biological life cycle, whatever life cycle, so it's in software life cycle also, There are several stages and identifiable stages. That means different, distinguishing stages are there. What are the stages? I will mention later. So several stages are there. Now, um, here, what is you can see that in case of business model, any business person launch that is he wants to launch a product, so he chalks out a plan. Okay, so this is a business process. So software lifecycle is just like similar to business process. That's why it is also known as software. As a software in short, many times I will write you SW, software process. So you can, that is anyone can say software lifecycle or process, both are of same meaning. And what is the thing that we want to discuss today? SLCM, yes, SLCM, software lifecycle model, is nothing but the descriptive and diagrammatic. I will show you the diagrams, diagrammatic representation of software lifecycle. Okay. That is the thing of software lifecycle model. Now, I will ask you one question that since from the beginning I am saying disciplined approach, software engineering discipline, so you have to follow a disciplined model. So you have to chalk out a plan before. So if any one of you argue that, sir, can we not build software ad hoc just like what we do in assignment? No, the answer is of course no, because you also can understand that to make a good thing, you have to plan accordingly, and you have to that is properly plan. That is what you do now and what you do next and what is the impact also. Everything you should know. If you do not know, that is the step-by-step procedure. If you do not chalk out, then you cannot finish with it time. And also the cost, that is if you need actually the software, if you plan out properly, suppose you need 10 workers, but if you do not plan, so every time you can see other workers also cannot that is cope up with the process. So you need some more workers also, and even you are using 15 workers, you cannot utilizing their resources because you do not, no one knows what is their actual work. So it should not be it will not be rather time and cost effective. So to make it time and cost effective, you have to sorry, you have to make that is a disciplined approach. Okay. Another thing why we have to model this, another thing is that you are, suppose you are writing that is you are completing your assignment, you are writing your code, your own code, but in case of software, it is you are not alone. You may have in a team 3 members there, or 30 members, 300 members are there, or even more. So you have to work, since you are working with a team, so everyone should know his or her responsibility. And please that is note this point, when to do what, to do what, when to do what. This will be required to understand these software lifecycle models, whatever model, iterative model, whatever the other models are there. When to do what, this is the thing we need to know. Since it is a teamwork, so you have to know this thing. And I will ask 2 questions. One thing is known to you, another is not. Reason for documentation. First, I will tell you what is documentation, and then I will ask you why is the documentation is required. Another is 99% complete syndrome. Complete syndrome. What is documentation? You have to write, that is whatever you are doing, what you do. We generally in your lab assignment, what do we do? Just we write the algorithm, and suppose in case of software, that is algorithm class or data structure class, we write the algorithm, that is the procedure. Then after that we start implementation. Maybe it's C, in Java, whatever the language you know. In this curriculum software engineering, I will not discuss much about this C or Java. This is for other teachers will be there for it. So So I am just thinking that you have a little bit knowledge of C and Java, then it is enough for you to understand this subject software engineer. So why documentation is required? So whenever you are writing anything, you are not that is whenever I will check your code. So first of all, I will face some difficulties. If suppose the number of lines is say 500, so it will be much more difficult for me to check to debug it compared to a 50 lines of code problem. So if you write it properly and say if you document it, that is this is the thing I have implemented. This is the task. This was our task, and this is my logic. And in this line number 1 to 10, I have implemented this. Line number 11 to 15, I have implemented this, and so on. Then it will be easier for you and anyone of your team to debug it. That is the thing here. This is a required thing for this is actually known as documentation. And I told you that's why the documentation is required. Whenever you will write anything, suppose when teacher, every time teacher says that, sir, I cannot understand this thing, or how will that is memorize everything. So teacher will say you that you have to write. Whatever you study, please write it, jot it down. So what we will get that if you have some inconsistency or incompleteness in understanding, whenever you write anything, it will be clear or clearer. So documentation purpose, it is also in your syllabus is there. If you do not know documentation, this in software engineering is not, I am again saying that is not about writing not only about writing the code. It is software engineering is mostly about chalking out or planning the steps and documentation. Documentation is the very important point of software engineering. So here, if you write, so you can discover the inconsistency. Inconsistency may be from user. So whatever user is suggesting or wants to get from you, maybe there is some consistency that you cannot provide, or it is not possible enough. That is first of all, whatever you will develop, whenever you will develop a software, you need to do the feasibility study. Na? So whether this is possible to implement, or when that, or it is possible for your company, organization to implement it, to make the software. So this is known as feasibility study. So right now, forget about it. So whatever the user is saying, there may be some inconsistency in his saying. So or incompleteness is there. So you'll rectify it. So incompleteness, just I'm writing incompleteness, inconsistency there, and some redundancy also there. Okay. So these things will be overcome by documentation. Now, what is 99% complete syndrome? Please look at here, when to do what. So there are lots of, I have said, identifiable stages there. So lots of stages are there in a life cycle, software life cycle model. Now, after one stage, there next stage will start. But when the next stage will start, it depends on the previous one. The previous one should complete, then only the next stage will start. So you have to know when the previous stage, or you have to when you will complete the stage. For example, the first stage is generally to collect information from the user, requirement, specification, and analysis. Analyze. So what is there? So whatever the user suggests, so you have to review internally within your team members. Yes, user is suggesting this thing, so whether it can be possible and what to do, and you are jotting down, and this you are having meeting with your team members, and then you submit, you write, this is the things, so please approve or please add anything you want. So ask the user or customer. So customer, that is first of all, customer is your god, that is the god of the organization. So he is paying, and so whenever the customer will approve, then only you can send the that is all the requirements to your legal team, so you can sign the document, or you can sign the MOU with the customer. Okay, so then only whenever user approves, otherwise you cannot, then only you can start the next step, next design step. First step is just collecting information and taking the approval from the user, then you can start the design, that is writing the algorithm, mathematical logic, and then coding and so on. So how long this is not done, you cannot start design. That the workers, the members involved in design phase, they cannot start work if this step is not there. So you should have, the software developer should have the clear idea when one step will end. And this is actually leads, if you do not have, what will be there? This will actually, the project will fail. Why? If you do not have that idea, that is, most of us, is our psychology that yes, we are done, almost done, so we can end, we can start the next process. If you do not have the specific points, suppose here we have specific point, 10 points are there, but some of the company is not recording this thing, so they are just that is having some intuition, that is they are collecting user, that is collecting the information from the user and just making it the review internally and with the customer, but not stepwise, in orderly fashion. And they have not even sent to the legal team because they do not know when to do. Because if I jot down, this is the point number 1 is sitting with the client. Point number 2 is internal meeting. Point number 3 is approval from the user. Point number 4, meeting with the that is the request or approval from the user. So meeting with the legal team up to sign the move. If all these steps are done, then you can assure your first step is over. But if it's not jotted down, then you will think that we are almost done. Almost means 99% done. May be possible that you are nothing. You are far away from your completion of this step. So that is project manager cannot figure out where you are. So that is 99% complete syndrome. Still, I have not yet in the actual software engineering part. Now I will come to this model, SLC, software lifecycle model. I think software lifecycle model. If you have any doubt, do not hesitate. Please ask me. We do not have any end semester exam. By the end of the day, you have to get placed. SLC model, software lifecycle model. First, I will discuss about classical. I'll write the term classical waterfall model. Classical, that means it is mathematical or theoretical. Really, in the real scenario, it is not possible to implement. Still, why, sir, you are saying this classical model? Because all other models are based on this model. If you understand classical model, you just a little bit changes there, and then you can understand other models also. So you don't need to blindly memorize it. Here, okay. So what I'm saying here, first of all, I have mentioned you that one thing I mentioned, there are model means there are several stages, and also I have mentioned what is the first stage. First stage is sitting with the customer or user, then that is collect his requirements and approve from the customer whether he is actually requesting for it or not. This is required. So I will write down here the steps here, draw here. First step is requirement analysis and specification. Next step is the design. I have also mentioned that is designing the logic or algorithm. Then comes coding and unit testing. That is module by module. Independently, you have to check module by module or function by function. I am coming to it, and I will also discuss it elaborately. Integration and system testing. That is, you have to check your entire system. Then finally, maintenance. This is the most here. Maintenance, you need maximum effort here. Around 60% is the in the literature you find 60% or above is required for maintenance. Most of the effort will be there for maintenance, and for rest of the others, integration also the next one, where we need, apart from maintenance, where we need maximum effort in integration and system testing. And this is our syllabus of software engineering. This is the step today. I do not discuss it completely, and next day that is I will discuss SRS, design and coding and testing, system testing. Okay, so this is our actually syllabus. Okay, so what is there in requirement analysis and specification? Okay, it looks like a cascade of waterfall. That's why it is known as waterfall mode. So you can look like it's a cascade of waterfall. So please understand it. Then you can that is you do not need to memorize. After this class, you will be able to say instantly that whenever you will be asked in the interview, what are the steps in classical waterfall model? These are the steps. First, you have to meet with your user. Now come to the first point. I don't want to waste much time here. It's already 6. We have 1 hour left. Sorry, half an hour left. So requirement analysis and specification. So we have to sit with the customer, and what we do, there are 2 steps are there in step 1. First, we have to gather the requirements of the customer, requirement gathering or collecting, and analysis. What is analysis? Analysis means we have collected the requirements, what he requires, he wants from us. Now we have to, that is our team is experienced, our team is skillful, so he can understand. Suppose user is not so much aware, so he is missing out some point. So you have to that is remove those incompleteness and any inconsistency also in the words of the customer, inconsistencies. Okay, you have to remove it. Now after you remove these things, so what you need to do, you have to document it. It is known as requirements specification. Okay, specification. So you have to specify the requirements. That means you have to produce a document. It is known as SRS. Who can say the term? SRS, software requirement specification. Okay, specification. So that is in the document SRS. That is at the end of the class. I will ask you, and I will show you how to produce a SRS. That is a documentation. And one thing I will say that you have to know. I will show you some packages in Python that that are used for also reverse engineering. That is produce the documentation. That helps us. You can see also that is actually LumPy. It will not help you to that is give you the documentation, but it will help you somewhat. Okay, next comes, that is you have gathered the information, you have removed redundancy, incompleteness in the statement of the user, and also if you have anything in the understanding of the from your side, then you are documenting it. Okay, then you will produce it to the customer, he will approve. Then what is in step 2? You can now, after all this done, you can go for design part. Design means you have to perform, that is prepare the logic. Okay, that means the document, from the document you produce, you have to devise the algorithm. So there are 2 approaches. One is mostly used, traditional approach. Another is object-oriented approach. This is also used. Object-oriented approach. So in traditional approach, you have to learn DFD, data flow diagram. Diagrammatically, you will represent it. So it will be again discussed later elaborately. And also here UML diagrams I will discuss. So you can see in the lesson plan. Now step 3. What is step 3 there? Please recall. So after designing, that is we have the logic. That is, we have the flowchart say. So if we have the flowchart, so please, that is, try to get the analogy of flowchart. That if you have the flowchart, so then you can code it. Okay. So that we will start here. So step 3 is coding and unit testing. What is coding? You have to write in any programming language, but you have to keep it in mind coding standards. What is coding standard? Maybe many of you are hearing this term for the first time, and that is from today onwards, if you write a single code, I will suggest you please write following the coding standard. What is coding standard? What you do in your lab, that is whenever is C programming or Java programming, whatever, Python even, you just write, you take some variable x, y, z, mostly, not everyone. You take the variables x, y, z, and also some, for functions you represent like foo1, whatever, f1, whatever comes to your mind, you write. But don't do this. Suppose you want to say it is result, so you can use res or rest. Suppose it is auxiliary variable, you can use aux. Okay. Suppose the function is like uh, say multiplication, or in short you can write mul and the parameters. But if you write who, we have to check your entire code, what you have written, what is there, is multiplication there or anything else is there, we have to check it. So try to give the name and also your program name, so that it is relevant to get your idea. And also suppose you are writing, say suppose I am writing void addition. Okay, simple example. So before writing, just give a comment line. So this is, just write in short, this is actually addition function. I'm giving you a simple example. So try to give comments also. This is the coding standard. Whenever you will be working for any company, you have to follow this, their template, their header template. They will provide you their headers, and also variable function naming conventions. They will ask you to follow it, and also maximum number of lines of codes they are allowing. That you need to follow, because lines of code is also very important metric. Because if lines of code is higher, your cost will be higher. So company will not allow you. You will it's up to your wish. You will just write. If it can be done in 100 lines, you are writing in 1,000 lines. So company will not that is allow you. So you have to follow these coding standards. So from the next time today onwards, if you write any code, not use XYZ, foo1, f1, f2. Please give some names. So that you can get it habituated from the beginning. And also unit testing. Unit testing means what we do, if someone writes the entire thing, you know, I think I am very much confident that you all know that what is the requirement of function in C programming or other programming. Functions are required. Why functions are required? If you write just a code line by line, it is very much difficult to track. Okay. Also other things are required there, maintenance, that is debugging is there, reusability is not possible. So we use just what, use functions. So there are lots of functions or modules are there. There is some set of some lines of code segments are there. So you have to check or test it. This is unit testing. How we can test it will be discussed later, but you have to check module wise. Unit testing means you have to check module or function wise. Next, step number 4. Step number 4, what is there? Integration and system testing. Integration means there are lots of, suppose there are 10 modules are there. So you have to integrate into the system, that is into a single software. Okay. But you can, just like addition, normal algebraic addition, you cannot integrate. What you can do in place, you have to add module by module. First you have added a module 1, say module 1 is added, then test it, then module 2 is also added, then test it again, and so on. So after finding out, that is after sorry, not finding, after integrating all the modules, you have to, this is the entire system, you have to test it. This is known as testing the entire system, is system testing. System testing. Now there are different types of system testing is there. System testings are of different kinds. Alpha testing. Again, I am saying here in the life cycle, we are just getting to know what is the actual software engineering. Of course, it is not possible to one day to demonstrate everything, but you can see after one class, you are that is at least the idea what is there in software engineering, what is software engineering, and what is there in the software engineering. Beta testing and here it is acceptance testing. Acceptance testing. Who can say what is alpha testing? Anyone there? It is completely one-way communication so far. I have not seen any response. So if you do not respond, also you please say, is this portion is required for me? I will also teach this portion from software engineering. So this is required. So I will, of course, discuss it by how much is possible. Okay. So please tell me, anyone. You can also Google, no problem. You can give wrong answer, no problem. Please tell me what is alpha testing and beta testing from the point of view. Okay, I am giving you a hint. In which of the three testing developer test the system? In alpha testing, developer test, or beta testing? Testing is done by the
alpha.
Yes.
In alpha, the developer tests the system.
Very good. In alpha, developer tests the system. Very good. And beta testing here, actually there are some actually you can see some networks it builds whenever you your organization is there is running some years, even you get some network. So they will test. That is, some friendly customers are there. They will test also. That is, they will also put some suggestions and comments there. This is beta testing. Alpha is your actual internal body. That is, after developers are testing. And finally, who is the god? Customer is the god. So he is giving the money. So acceptance testing means is up to the customer now. Whatever you will do, if customer rejects this, so it is over. So your project fails. So you have to do again. You have to again start from the beginning. So acceptance testing is done by the customer or user. Okay. So whether if it is accepted, then you can deliver the product, and then comes the last step, maintenance. Step number 5, maintenance. And it is most effort is there.
Sir, what is the difference between the beta testing and acceptance testing?
Yes, actually, you are beta testing. You are not actually provided. Suppose I am the customer, okay, and you are the developer. So you are not providing it to me before handing it the that is before handing over the software to me for checking. So you will just check it. That is how much correct it can be. So first you will check internally with your team members. Then you will check your, that is well known. That is, they actually, you are known. They are reliable to you. They are in some network. There is connection with you, but they are not the actual customer whom you are providing the software. So you will say that we have developed the software. That please review my software. So, but actually, this is actually some policies are there, internal policies from the point of view of company. So this is there. So they will check it, but they are not the actual customer. They may be the customer previously. So also they are very much expert. So not any layman can be a friendly customer. So not only they are reliable, they also, there is some policies are there. So they will give the feedbacks. This is there. But beta testing means it's not actually tested by the actual customer. Acceptance testing means it is tested by the actual customer. Is it a bit clear?
Yes, sir.
Okay. Next, after the user customer approves it, then you have to maintain it. So it is, I have said that 60% of the effort is more for maintenance. If it is operating system, there will be several years there for maintenance. Okay. And if it is a suppose a business related software for a small business, and suppose the business is over, so business is not that particular business is not running currently, so the software is also obsolete. So in that case, there is nothing. The maintenance time duration will be less. So maintenance, of course, the most effort it needs, and the duration, the span of maintenance can be 1 to 2 years to indefinite. That is how long your software is still in the market. For example, for operating system Windows 7 is still in the market. So this maintenance is also required. So and also just there are different kinds of maintenance I want to mention before stopping this particular model, ending here. So corrective maintenance is there. What is corrective maintenance? User pointing out that, sir, you actually this was missed out during this thing, during development. So this is suppose that there's crashes is there, or anything, any debug customer is facing. So you have to rectify it. Perfective maintenance is mostly from your side, that's developer side. Perfective means, so suppose user has not provided, user is not so skillful, user may that is suggest you, give you some suggestion, feedback, but perfective is actually, it is desired that it will come from developer side. Perfective means you want to improve your software so that you have to live in the market. So you have to make your software better day by day. And last one is your adaptive maintenance. That is, suppose new platform has been there.
Sir, what was perfective? Sir, what was perfective maintenance again?
Sorry, I could not hear your voice was cracking.
So can you explain perfective maintenance again?
Yes, sure. Perfective maintenance. So perfective maintenance means this is not from the use, may not be. I'm not saying maybe user is the very that is, he has a very good sense or is very skillful, but mostly perfective maintenance means the developer is thinking that he has to improve this thing, so he can improve that particular software. That is improving, not that is that it is there is a debug. There may not be any debug, but is improving. That is how improve means the functionalities, number of functionalities that your software is providing. You can increase the number of functionalities more so that it is much more reliable. Okay, so not only to increase the functionalities, for example, say you are using suppose any operating system, say it is Windows 10. Now Windows 11 has come, but Windows 11 there are some issues are there. So functionalities are more, but if there is reliability is less, that is not desired. So perfective here, you have to increase your functionalities, and also it should be reliable enough that it will not crash or any issue will not be found. So that will be from developer side. The developer will think that how we can increase the number of functionalities there. So that is perfective. Corrective means you have to debug. There is some issue there. Perfect means you have to increase the features. Adaptive means, yeah, is it clear? Perfective. Oniket?
Yes, sir. Yes, sir. Yes, sir.
Okay. Adaptive is there. Suppose a new platform is there, has come to the market. So that is, or a new operating system has been launched. So your software should, since you have to stay in the market, you have to live in the market, better to say. So you have to fight with others. So if your software is obsolete for the newly launched operating systems, so others will come in place of you. The market is very hard, reality is very hard. So you have to, every time you have to be perfect, more perfect. That is as much as you can, and also adaptive also. Whenever a new things will come, you have to cope up. That is, your software should cope up with. So these are the things, steps or stages, identifiable stages. That means identifiable means this is actually not one thing, because specification is not actual. That is completely different compared to design. Design is completely different from coding. So these are identifiable stage. So there are these stages are there, but classical model cannot this classical. That's why the classical, it is not realistic. Is what waterfall I have mentioned. It looks like a cascade, so it cannot be implemented in a realistic. Why? what are the shortcomings, or three shortcomings I will say, that is drawbacks here, that can be asked every time. It is a very common, whatever the things I am asking, this is a common interview questions from the basics of software engineering. If I do not go into deeper in the software engineering, this is a basic question. So first one is that we have considered here that after this stage we are starting this stage. So we are not thinking about this anything error here. If anything error is there, so that means here we are not considering. Suppose anything is there, anything error is there. So what we'll do? We are not doing anything. In this model, if there is error in the design, we are still coding. Okay, so error actually propagates here. So that is the problem here. So that is not realistic. There should be actually, or there in practice, there is some errors there at every stage. So whenever in the next stage you find any error in the previous stage, you have to go back. You have to go back. This is feedback. You have to go back. Suppose in coding, you see the error is there in design or error is there in the requirements. You have to go back. That is known as feedback. So these feedback paths are there every preceding phases. So from integration testing, you can see here error is there. You have to rectify it, and from maintenance also. So if I change this, so this model is known as, now classical waterfall model is changed into iterative waterfall model. This is also waterfall, but iterative waterfall model. Why iterative? Waterfall model.
Sir, can you please explain the iterative ones?
Yes, sure. So here you can see this arrow, the feedbacks were not there in case of what? In case of classical model.
Yes, sir.
So this was not there. Okay. So what we'll do? You can see we have not. Suppose if there is any error in specifying the documents, or if there is any design error, we should go back. Suppose in design error, we are still we should not code it. We should first rectify the error. While suppose we are writing the code, we face that there is some error in the design. We should do what? We should rectify the error in design, right? So we have to return back or go back to the previous stage, then rectify it. So, but this is not done in waterfall model. So after completing one stage, we are thinking that this is completely done. The error is no error is there. We are going back, going to the next stage, and then we are moving forward, this way. But actually, in real life, of course, there is some error in every stage. So whenever is there, suppose in design, I can see that there is error in requirement. So I'll go back in requirement specification and rectify it. Then again, I will come back design part. Suppose while coding, I can see the error is there in design part. Maybe the error is there in requirement part. So you have to go back and then come back sequentially, right? Is it clear?
Yes, sir.
Yes, sir.
Okay, good. So this is known as iterative model. Now, another thing is that another shortcoming for classical waterfall model. This is actually done. This is classical waterfall model here. When you can see there is error in previous step, we are rectifying it by going back to the previous step. This is rectified. This is resolved in iterative model. But other errors are not resolved. What are the other two errors? Other two errors of classical waterfall model are that one is that so you can see that you are at the beginning, you are collecting the user, that is the requirements of the user, right? At the beginning, you are collecting all the information from the user, and you are thinking that it will not change, user requirements will never change, and you will complete and then finally hand over to the user. But in real life, it is not actually not possible. At the middle of the stage, user can call you that, sir, I want to change this thing. So user can change his mind. So that is not here in classical. Even in, you can see in the diagram of iterative model, also it is not considered. So we that is whatever user provided at the beginning, we just thoroughly want that is follow the all the stages and do one by one. We do not think that user can also change his mind. We don't consider it, but that is not actually realistic. Another thing is that here all the phases are sequential. That is, after completing this step, we are designing. That means requirement. Suppose there are several members are there. Suppose 5 members are there in requirement specification. That is, they are application engineer. They are collecting. They are on the field. They are collecting information from the customer or user. And there are suppose 5 members are there in design part. There are 10 members in coding. There are say 20 members in this. Now say there are 30 members are there. So all the actually suppose when it is started, the process is started. Suppose coding is there. So will design the members involved in design they will sit idle. Here in classical order waterfall model and iterative waterfall model, we can see they will sit idle. Whenever coding starts, design part they have nothing to do. After this part, if there is issue, they will go back. Then they will work again. But that is not a real scenario. Design, those who are involved in design, they are also working. They are communicating with coding, because one day, that is sequentially, it is not possible to develop one software. Okay, so this is another drawback is there. So for that, what is another approach is there. So it is known as sorry, prototype model. Prototype model. So what is prototype model? You are actually doing what? I will just a few minutes more. So you are doing what? So after this iterative, that is sequence, that is classical or iterative waterfall model, you are sequentially doing this thing. And if the customer rejects it, you have to start from the scratch again. That is whatever the cost, whatever the money you are paying to your say to buying the resources, to your workers, everything got lost. Actually, nothing, everything into got into vain. But if you think in such a way that suppose you want to that is you will build the system quickly, that is you will not provide the customer all the facilities. You will just build a prototype. Prototype, you all know, in several fields prototype is a very common term. Prototype, that is a implementation, or better to say toy implementation. That's not an actual software. You are building a toy software or prototype software. Now you are handing over to the customer. So customer says that no, it is sir, it is not meeting meeting up my requirements. So please change it. So again you can change it. Again, the customer is not happy. Again you can change it. After certain point of time, customer will be happy, and then you can start the actual design part. But why the prototype is we are doing handing over the prototype in place of entire software? If you think logically or from the realistic point of view, in place of handing over the entire software, we are just handing over the toy or prototype software. The advantage is there. If we hand over the toy software, then to build the toy software, prototype software, the cost is not so much. In place of developing the entire software, to develop a toy software, that is toy software means what? All the features are not there. Just mainly features, that is only those features are required to know the feedback from the customer. Whether this type of thing, that is this type of software is requiring or not. So this is required. So this prototype we are handing over. And in software engineering, knowledge or experience is very much, knowledge is of course required, skill is required, but experience is very much important thing or very much desirable. Experienced persons are mostly desirable there. If we provide the prototype to the customer, and after several times, then that is after sometimes he will say that yes, I can approve, you can now implement the entire, that is actual software, and hand over to me. So that you can see, that is whenever user is rejecting, so you are getting some insight, you are getting some experience. So that will help you to understand that what actually some user is asking from you, and you can get that knowledge even before implementing the entire software. That will help us, because entire software again you are starting from the sketch, then your entire work actually went into bin, right? So nothing, no, actually a huge loss is there for your company. So we'll do what? We'll build a prototype. So here the model is a bit change is there. I will need the 3 minutes more. Requirement gathering. I just Soinik sir, I think will take the class. Quick design. Actually, I'm college today. That's why I changed the schedule. Build now the prototype. Okay, quick design means just only the few things you have to keep in mind, few features we are providing. Now, customer feedback or evaluation in short. Don't write this short because I do not have some much time. Then refine it. Customer rejects it, then refine and again quick design. After a point of time, he will satisfy. Then start the design part, just like a classical or iterative model. Then implement. That is coding and unit testing. Then integration and system testing. Then maintenance finally. Okay, and also you have to go back. This is required. This feedback is required. Okay, so this portion, just a minute. This portion is iterative model, and the previous prototype portion, that is from the requirement specification and quick design, is prototype development. Entirely this is prototype model. Okay, another model is there, spiral model, but I will not discuss it. I will rather suggest you one thing is there in spiral. Just I will end here saying spiral model, it is the only model where risk is measured. No, none of the other two models you can see risk is there. I have not written any term related to risk there, and actually my handwriting is not so good here. So whatever. So whenever you can see that is not you cannot understand any of my writing, please tell. Next day actually for some mathematical, and so it will be there. And please study this thing so that you can get the insight. If you have any doubt, so I will end it by 1 minute. I want to end it. I will just stop the recording here.